All right, so today we want to give an introduction to Chapter 1, Section 3. And so our opening slide reminds us that we're looking at Chapter 1. And Chapter 1 is the Introduction to Statistics. 1.1, which we talked about last week, was Statistical and Critical Thinking. 1.2 is Types of Data. I talked about that in an earlier class, and that video will be posted for people who would like to see this kind of an introduction, but for 1.2. And then now we're going to go ahead and look at 1.3, collecting sample data. So the big picture in 1.1, just to wrap our minds around what the chapter is trying to do for us, was to introduce the idea of statistics, in particular when there's a larger population and you are wanting to find out something about some aspect of the population. My discussion example was, I want to know for all the students at DVC, on average, how tall students are. And so the big idea of statistics is that you would most of the time take a sample from the population and then look at the data from your sample to then infer or draw conclusions about the overall population on a whole. And that's the idea of statistics. So in 1.2, the discussion focused on the kinds of data that you might collect and being able to discuss and label different kinds of data: numerical data, categorical data, nominal data, ordinal data. There was a whole bunch of definitions in 1.2. And so if you're getting confused by some of those words about types of data, then 1.2 is the place to review that. So now, having done that in those first two sections, in 1.3, we're going to talk about actually the process of collecting data. So we've talked about the kind of data you may be looking at. And in 1.3, we want to talk about how you collect that data and for what purpose, what the different ways to use that in statistics looks like. So that's why in 1.3, we're looking at collecting the sample data itself. So moving forward, let's look at our key concept for the section. The method used to collect sample data influences the quality of the statistical analysis. Of particular importance is the simple random sample. And they will define what that means a little later in the section. So even though they're using that and saying this is of importance, we have to understand that they haven't told us what that means exactly at this point. And that's okay, that's normal. But it is very important, and you will, for the rest of the semester, often see the word simple random sample used and refer to a sample that was collected. It says, if sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. And so the basic idea here is that when you are collecting data, how you collect the data is very, very important to see if it's a reliable predictor or representative of what's going on in the overall population. So let me just give you a simple example, which hopefully might be on its face understandable. And then we'll move forward and look at definitions. So let's say I was still interested in figuring out on average how tall students at DVC are. And so I was going to collect my sample of students and measure how tall they were in order to then look at that and hopefully get a feeling that that's some idea of what it's like for the overall population. So imagine that in my desire to understand the overall population and collect my sample, I went onto campus and I said, well, just for ease or convenience, what I'm going to do is I'm going to ask people if they'd allow me to measure how tall they are, or for them to tell me how tall they are if they know. And I'm going to do that over by the gym as players are coming out from a student basketball game. And then as the students who played in the basketball game are coming out, I'm going to figure out how tall they are one way or another, and that's going to be my sample. So what do you guys think about that?
It's biased.
Biased. So what does that mean?
It means that the sample of data that you took it's going to be skewed in a certain direction because well, for this particular example, basketball players tend to be taller, so you're not going to get accurate information for your sample.
Very well said. Very well said. Yes. And so we have to remember what the goal is. The goal is to try to be able to look at the results of our sample, to have that be a good representation of what's going on in the overall population. And if the bias, as perfectly described there, causes the results of my sample to be very, very different than the average results of my population, then that could make the work that I did collecting that sample and taking the average completely a waste of time. Or as they describe here on this slide, utterly useless. And that has to do with the way I collected data. So how we collect data, trying to stay true to our goal of having data that's a good representation of the general population, is the sort of at the heart of this key concept for 1.3. And so this particular importance, this simple random sample, will be discussed later and defined clearly as a way to attempt to have the best chance to have the sample data that you collect be a good, unbiased representation of the parameter or the data values of the overall population that you're trying to investigate. Any questions, comments, discussions about this big idea before we get into the nitty-gritty? Okay, so at this point there will begin to be an onslaught of new words provided so that we can literally talk about it and refer to different ways of collecting data and definitions to begin to try to understand. So the gold standard, randomization with placebo/treatment groups, is sometimes called the gold standard because it is so effective. A placebo, such as a sugar pill, has no medicinal effect. So they're referring to this idea that we are trying to do statistical work in a way that we get the best information we can. And the thing they're referring to here is randomization, in which instead of me picking people as they come from a basketball game, I somehow try to randomize which students on campus I choose. And also possibly a placebo treatment. So if I'm trying to run a statistical experiment, and they'll define that in just a second, where I'm trying to see the effect of something, then one of the gold standards is to also have something that looks like you're applying a treatment, but that actually the treatment wouldn't have any medicinal effect, called a placebo. And maybe you've heard of that before, maybe not, but the examples hopefully will help illustrate the meaning of what this gold standard is that we're searching for. All right, so let's move in. So the basics of collecting data. So the first thing to point out is that statistical methods are driven by the data that we collect, as we've just been discussing. Bad data means bad results. We typically obtain data from two distinct sources. Not that every time you do statistics, you use both of these things, but there's two sort of ways or methods of collecting data. One is observational studies, and the other is experiments. So we need to know what those mean. So first, an experiment. So an experiment is where we apply some treatment and then proceed to observe its effects on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. So it might not be people. It might be that you are doing a treatment on some physical object to see the effect of the treatment. But certainly you can imagine very quickly, like if you're testing medicine or things like that, that you have subjects that are people and that you give them a trial sample of something and see what the effect is. So that's an example of an experiment. Any questions, comments about this? Or can someone think of an experiment that might be done and provided as an imaginary example?
I might have one.
Okay.
Like scientists experiment new vaccines on other animals like apes before they treat people, so they'll give them that treatment and then observe them.
That's a great example. And like we now have this big issue with vaccines being distributed all over the world, and some people being worried that maybe they were distributed when they're not safe, and other people anxious to get the vaccine and things like that. So you would hope that some sort of experimentation was done on the vaccine before it was given. And you don't, in order to have an experiment, you wouldn't need to have what was just described where you weren't using it on humans first. So you can have an experiment on, let's say, chimpanzees, and the treatment was that you provided a vaccine, and then you see whether there were side effects, and you make observations about whether the giving of the vaccine seemed to produce some sort of effects. First of all, did it work for what you were trying to accomplish? And did it have unintended consequences? And if so, how severe? But you could also run that exact same kind of an experiment on people, in which you would probably somehow get people that were willing to be experimented on. And guaranteed there were people who were experimented on with the vaccine that is now being widely distributed for hopefully fighting COVID. So those are good examples of an experiment, and that is an example of a statistical process using statistics. All right, so then let's compare that to an observational study, which are much more common because they are much easier to do, less expensive, less time consuming. So observing and measuring specific characteristics without attempting to modify the individuals being studied. So the key thing about observational is that you just observe, you don't do anything to what's being observed, to your sample, to your subjects, whatever it is. You do not do anything to them. You don't modify the individuals, you just take a look. And so my example of wanting to measure how tall students at BBC are by looking at some sample of students is an example of an observational study. I'm not trying to apply some treatment to see if they get taller or shorter or something. I'm just trying to take a look at how tall they are. Anybody have a question, comment, or want to provide an example of an observational study?
Professor, I had I don't know, it's a comment or like an example. For example, I'm studying to become a teacher, and we do lots of observations in children to identify their interests. So it could be an example of observational study.
Well, yes, in the world of statistics, it would become more of a statistical observational study if, when you were making those observations and you talked about their interests, if you collected those observations, because then you are collecting data. So if you, as you were observing students and their interests, if you were, for example, making notes of their interests,
Yes,
and look at those results later to then do something like make a good
curriculum
plan or something like that,
yeah.
then that moves into the world of statistics. Does that make sense?
Okay, yes.
But if you are, for example, just kind of watching other teachers to learn teaching methods, that doesn't really become as much of a statistical thing because you're not really collecting data other than mentally learning from what they're doing, if that makes sense.
Okay, yes.
Yeah, so that's a great example because we could kind of look at something that kind of sounds statistical, observational study, but what moves it into statistic is the ability to collect those observations with some sort of data and then analyze that data in order to then make use of it, the results. That's when it becomes statistics. Great example. Anybody else want to ask a question or offer up an example of a sort of imaginary observational study? All right, so as I mentioned earlier, I will reiterate that I do recommend as we pause here, that you try to stay engaged and become involved in helping these words begin to have meaning for you. Your brain, in order to have this vocabulary become useful and understandable, has to try to apply it in some way. And even if you don't want to share with the class, that's not a problem. But as we take these pauses, try in your mind to come up with and create examples of what's being described, because that way your brain will be able to use these words and retain this information sooner and for longer. If you just kind of have it go in one ear and out the other, it's very easy for all of these words within 1 week to not make any sense, because your brain didn't really latch onto them in a meaningful way. So I'm going to continue to encourage people. I'm not saying you need to speak up. By all means, if you prefer not to share with the class, that is not a problem. But even so, even if you don't intend to share with the class, please still try to come up with your own examples in your mind. And then, of course, at some point, if you do and you're wondering if that's a good example and you're willing to share it, then we can talk about it together. And that would be best for everybody. All right, so having said that, let's continue. So here's an example that they're providing. What I've often found is that the book, and therefore as reflected by these slides, when they're giving examples of things, sometimes the examples they give are, first of all, they're all real world examples of actual things that were studied or done, statistical work that had been done. And what that means is sometimes it very quickly becomes a little bit more involved or intricate. And sometimes it's not the simplest and easiest way to begin to understand the topics being discussed. And so that's why sometimes I like to have very simple examples that we talk about first, and then we can go into more detailed ones as they provide them. So here's an example. 1 of 2 means that there are 2 slides discussing this example, and this is the first of those 2. And also as a reminder, we won't get through this whole slideshow today, but all of the slideshows we're looking at now are available in the multimedia library, and you guys can access them if you want to review them later and look at some of the slides we didn't get to. So an example of an observational study: observed past data to conclude that ice cream causes drownings, based on data showing that increases in ice cream sales are associated with increases in drownings. So they're saying that this was something pursued, but they're pointing out that there's a mistake here. The mistake is to miss the lurking variable of temperature and the failure to see that as temperature increases, ice cream sales increase and drownings increase because more people go swimming when it gets hotter. So what they're right off the bat, so this isn't the simplest example to begin with. That's why I was discussing this a second ago. But right off the bat, they're showing that if you were trying to look at past data to try to see if it supports a conclusion that ice cream causes drownings, and the way you looked at that was to see, look, when there's more ice cream being sold, more people drown, that connection is not necessarily causational. That it may not be the increase in the ice cream that's causing an increase of drowning. It might just be that both are going up because the weather's real hot, so more people are eating ice cream and more people are swimming. So this is an example of the challenge in designing statistical studies and observational or experimental of nature, in that you have to design something that gets to the issue that you're trying to explore. And observing histories of the two will not establish anything between the two being causal, meaning that ice cream is actually what caused more drownings. So in the follow-up to this, it says if you were trying to investigate this with an experiment instead of an observational study, you could conduct an experiment with one group treated with ice cream. I want the ice cream group, while another group gets no ice cream. And then you could see if the rate of drowning victims changed or if it's about the same. So that you could really look to see if the difference in the groups was that one ate some ice cream and the other didn't. And if that group that actually ate ice cream had a higher rate of drowning, then maybe you could say there's this causational effect because that was the only thing that was different between the two groups. So this is designed to try to illustrate with this first example the difference between an experimental study and an observational study, and why you might choose one over the other. So it says here, the experiment is clearly better than the observational study, because since you're controlling with the groups that the only significant difference seems to be that this group had ice cream. If that group then has a higher rate of drowning, it might be a better argument that ice cream might have been the cause of that, since that seems to be the primary difference between the two. But if you just look historically at whether people eat more ice cream at the same time that there's more drownings, it's hard to connect whether one caused the other or whether some lurking variable caused both of them. Questions, comments about this example or these ideas? Discussion? All right, so we had a nice example earlier of a possible experiment being done where we talked about vaccines on chimps. We had a discussion about a possible observational study where you observed children and their interests. Can we have some more examples? And this time we try to classify whether we're giving an example of an experimental study versus an observational study. Anybody willing to offer up an example of that? And if you don't want to offer it up, can you try to think of one just to help your mind wrap your thoughts around this idea?
An example of an experiment could be if somebody wanted to test if a new painkiller works. So they had two groups, one that got the real painkiller and one that was given a placebo, and they saw how each group was affected, and they would see the differences in how the actual pill affected participants in comparison to what the placebo did.
And that's a good example because it has that gold standard in it that was referred to earlier, the idea of a placebo. So let's talk about that just for a second. Why don't you just give some people the pain pill and not give the pain pill to other people? Anybody have any thoughts about that?
You want both groups to think that they have the pill. And so I guess it's more of like a mindset is like, oh, I have the pill, I'm getting better. Even though you may not have the painkiller, it's sort of just like it tricks your brain into thinking that you're getting better. So sometimes you actually do get better, even though you've been given no treatment.
Yeah, that's a very, very good description. And the summation of that idea is called the placebo effect. So basically, if you give somebody a pill that has no medicinal impact at all, maybe made basically of sugar or something, but they have some reason to believe that it will help with their pain, that literally sometimes their mind implements that effect and it helps with their pain, even though there was nothing in it that should have done that.
Professor, I had a question. The thing that you just said is the blinding. Is that the blinding thing?
That's a good question. Blinding has to do with when you're running the experiment, who knows what. And there's blinding and double blinding. And we do have slides on that coming up. So you're like a couple slides ahead of us. So if you'll hang on to your question until we get there, I think I'll answer it for you when we're looking at the slides. Is that okay? Yeah,
yes.
So you're just a little ahead of us, which is great. But I promise I should be talking about that shortly, assuming we don't run out of time. We have a half hour, so we should be good. Yeah, so the placebo effect has been shown to be sometimes very powerful. And if you want to know whether medicine is really helping somebody, then you can't just give some people the medicine and not give the other people anything, because the people who got the medicine may say that it helped them when actually it wasn't the medicine that was helping them, it was really the placebo effect. And so instead you actually give everybody some pill and say that it might be medicine. And then some of them actually get the medicine and some of them don't, but nobody in the group knows whether they got the medicine or not. And then if the group that really got the medicine do have a higher effect of success than those who got the placebo, that would be stronger evidence that the medicine itself was actually having an impact and not just the idea of getting better after you took a pill. And so that's, if you hadn't heard of the placebo effect before or understand why it's important, when you're thinking about experiments, that becomes very important. And the offered up example of pain medication with a placebo is a great example of an experimental study. So let me ask a follow-up question. In statistics, we do experiments and observational studies, but we look at data, which we talked about, or which is covered in 1.2. So if we did the pain medication experimental study just described with a placebo and with the actual medicine, what would the data look like? What would we have recorded after that experiment, which we would then attempt to analyze? Can you think about what the data would look like?
I think that there could be two categories, and that would be patients that received the placebo pill and then the actual painkiller, and then the actual data under each category. And it could just be like, do you feel better? Or it can measure some actual like vital sign in their body that that could signify if they are getting better or not. Yeah, I think.
And can you now start to imagine different kinds of data and how that plays a part? So for example, the simplest would be what you first stated. You could literally ask them, do you feel the medicine helped you feel better? Yes or no? And that would be categorical data. And you would keep the two groups separate, and you would have a bunch of yeses and nos in the placebo group, and you would have a bunch of yeses and nos in the group who got the medicine. And maybe you would want to see if the group who got the medicine have a lot more yeses as a proportion of the group than the ones who got the placebo. And then that would maybe help you say it seems to be making more people feel they got better than if they didn't get it. But you could be much more calculative about it, and you could do something where something was measured. Now, what you would measure then becomes a question about how well you want to qualify whether people have been having good results from the pain medication. The kinds of things you may have already seen before is like, if you would rate the pain you're feeling on a scale from 1 to 10. If you've ever heard this kind of a thing in a doctor's show, or sad to say, because people are asking you how bad your pain is, if you ever heard that kind of a thing, that's part of why they do that. So what they could do is they could ask everybody who was experiencing some pain how strong the pain they're feeling was, then give them all either a placebo or the medicine, and then ask them on that same scale to reevaluate. And then you could compare averages, and you could do something more with a quantified values, with quantitative data, with numerical data. And you could say, well, the placebo effect caused there to be a 1-point increase on the average pain rating, or decrease, I'll say, let's say they felt better. Whereas the people who took the medicine had a 4-point decrease, and that seems to be much better. So you could make more of a quantified argument. So while we're thinking about these experiments, I think it'll serve you all well if you not only try to imagine what an experiment would look like, what kind of whether it's observational or an experiment type of a treatment, and also then what the data would look like at the end of that. The more you can put your mind in the frame of being involved in this process, the more the vocabulary will make sense, and the better you'll be able to transfer this learning we're doing now into when you're writing up your project or we're doing more challenging problems later. Questions, comments, discussions before we move on?
So, Professor, after like having the results of the experiment, then you like measure the results like as a, like if it was either nominal or ordinal level or things like that, is what you meant?
Right, meaning basically the way you observe what you're trying to look at and what you record about it will create what kind of data you have after you're done with your experiment. So if the way you observed whether people were feeling better after receiving or not receiving medication is by saying, are you feeling better, yes or no?
Yes. So which is like the nominal.
You've done that is a bunch of yeses and nos.
Okay.
And that's that kind of data. Does that make sense? Whereas if you give them a numerical scale to rate it on, then you're getting a numerical kind of data, and you can talk about what kind it is and what you can do with it.
Okay.
Does that
Yeah.
answer the question?
Yeah.
So for example, you guys, for your project at the end of the semester, you will be creating your own survey. And how you create your questions will directly determine what kind of data you can collect and you need to create questions that provide the kind of data that you can do the analysis for your project that is required. And we're learning all about these kinds of ideas now. All right, let's go on. So that was the end of that example. So now they're talking about the design of experiments. And we've just been talking about that a little bit, the idea of the use of a placebo or not. So here are some key things to think about in the design of an experiment. Replication is the repetition of an experiment on more than one individual. So you've kind of probably heard before anecdotal, like that's an anecdote is just one particular thing that was observed. So usually we don't want to just look at one instance of something. We'd like to be able to repeat experiments. I'm not going to give pain medication to one person and see if it worked. Instead, I want to be able to do that and repeat that same exact treatment over more than one individual. Good use of replication requires sample sizes that are large enough so that we can see effects of treatments, as an example. So obviously, more numbers, more data is kind of better. That's a simple thing to start to think about right away. And an example would be that if you're running some sort of an experiment, you want an experiment where you've applied it to multiple individuals instead of just a small number. Then blinding. So we had a question earlier about the blinding, and now we're getting to that. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. So in the example we discussed with pain medication, that was an experiment where we used blinding so that the people that we were observing in our experiment, the subjects, didn't know whether they got the medicine or not. And an example that I said earlier where you didn't do that, you just had a group of people and some of them you gave the medicine to and some people you didn't. Well, then blinding is not used because people who didn't take any pills know they didn't get any pain medication. And people who took this pill, if in your experiment they all received pain medication, then they would say, hey, I got pain medication. And so the dangers of not using blinding is that the placebo effect may not be accounted for correctly. So as it says here, blinding is a way to get around the placebo effect, which occurs when untreated subject reports an improvement in symptoms, meaning they were untreated because they had a placebo, not the real thing, but they still reported an improvement. So you want to get around that by comparing those results to people who actually did get the treatment. So let's immediately compare this to the next slide, which is double-blind experiments. In this case, blinding occurs at two levels. They use regular blinding. The subjects don't know whether he or she has received the treatment or the placebo. But additionally, you don't have the experimenter know either. The experimenter, the person implementing the treatment, does not know whether he or she is administering the treatment or placebo. And the reason for that is they've shown that not only do people, if they know they've received the treatment, sometimes report differently because of the placebo effect, but actually people are so in tune with just like picking up on cues with each other and are empathetic in general, that if the person who's giving the pill knows whether the pill is a placebo or is the actual medicine, they may give that fact away to the person they're giving it to. If they're looking later and recording the results, if the person received the treatment, the pain medication, and they say, yeah, my pain didn't get better at all, the experimenter may have had some expectation that it would get better because they got the real thing. And they said, really? They may react to that information differently and influence it. But if the experimenter also doesn't know who got the placebo and who got the treatment, then there's no way for them to give away that information or to react differently. And therefore the recording of the information, and they have no ability to influence the results either. And so that's called a double-blind experiment. So what might happen is, to do that with pain medication, you would have 50 of the pills are medicine, 50 of the pills are sugar, and you just randomly assign numbers from 1 to 100 to them, and then give those out to the people and record which, and the experimenter giving out the pill records that Joe got pill number 5, but they don't know whether pill number 5 was a placebo or was the medicine because that information is somewhere else. So that's an example of a double-blind experiment. So there's blinding where the subjects don't know what's going on, and there's double blinding where the subjects and the experimenters, the people implementing the experiment, also don't know who's got what. Questions, comments, discussions about that? In particular, the person with the question before about blinding, do you feel that answers your question?
Yes.
Anybody else want to discuss this or ask a question about it in any way?
Can you give an example of a double blind experiment?
Okay, and so we have the first example about giving medicine and the people giving it don't know whether they're giving it to it. You could modify that very easily where you're giving injections of medicine and the person giving the injection doesn't know whether it's the actual medicine or whether it's some simple like water or saline solution and they don't know which it is. You could go to something more fun or in the world of advertising or something. So you're doing a taste test and you want to see if the way you've changed your product, if people think it tastes better, but you don't want to tell them which one is the new version and which one's the old version, because they might just say the newer one tastes better to make you happy. So you say, hey, we're going to give you, or maybe it's brand A and brand B, and you don't want to know which brand is the one that the company who's running the experiment is actually the owner of that brand. Do you like Doritos better than some other tortilla chip? And so what you do is you take away the labels on the food being tested so they don't know which is which and ask them which one they think tastes better. So that's the blinding of the person. But then also the person giving them the food, when they see A and B, they don't know which is A or B either. And therefore, when they're recording which one the person liked better, they don't know whether the person liked Doritos better or not. And the person who's saying which one they liked better doesn't know if the one they liked better was the Doritos or not either. Is that a good enough example to answer your question? Does that make sense? Are you satisfied with that?
Yeah, that's pretty clear. Appreciate that.
I have a question.
Yes, please.
So that kind of reminds me of like Febreze commercials. Do you think that would like work as like just a regular blind?
I hate to say I'm not familiar with the Febreze commercial, so you'd have to give me a little more details.
Okay, so basically, random people are brought into a room that is like super messy and it looks like it smells like awful, and they're blindfolded. So they're like, "Oh, what do you think? Like, how does the room smell?"
Mm-hmm.
And they're like, "Oh, it smells pretty good." And then they take the blindfold off, and it goes something like that, where they're like, "Oh, wait. Like the room's super messy and looks like it smells awful." So I guess they're kind of showing whether like the product works or not.
All right, so what I would say is that is not an example of a blind, because for a blind experiment, you need to have two different things occur and the people don't know which one occurred to them. So if they did that, and the blindfold was there so that people didn't know if they were, so the blindfold is there because if you walk into a room that looks messy and nasty, then you may visually react to that and say that it stinks because of what you see and not because of what you actually smell. But you're not distinguishing between that. Like if you blindfold people and walk them in a room and say, how does it smell? Maybe they all just say, oh, it smells good, because they don't want you to feel bad. And they are imagining that, you know, they know they're there to smell something, right? So the question would be, if they put two rooms, one of them had the Febreze and one of them didn't, and they both were equally messy, and then they sent them in, then they could do that. In fact, ideally, they don't even really need the blindfold. So I think the blindfold is the gimmick and the sales technique, but that is not a blind experiment. Does that make sense?
Oh, yeah.
In this case, blind doesn't mean that they're actually blinded. It's supposed to be that they are unaware of the difference between whether they're a group that got a treatment versus a group that did not get the treatment, so that you can compare the two. But it sounds like in this case, there was only one group and they all got the treatment. And so it's hard to tell whether there was a placebo effect to that or not. Does that make sense?
Yeah, I think I took it too literally.
Well, and think of it this way, you know, as soon as advertising comes into play, experiments and statistics are often manipulated. because they want a particular result. They don't want the truth. And so it could be that they found that when they treated a room with Febreze and a room with wasn't treated, and they were both messy, that the Febreze room didn't get much better results. So instead, it seemed like everybody was aiming to please the experimenter by saying nice things. And so they said, well, let's put on the blind on them, and by making them blindfolded, and then they'll just say nice things, even if it stinks. You know what I'm saying? So that's a great example, actually. All right, so let's move on. What are we doing? Got. I want to see if we can get in one or two more vocabularies here. So let's look at this last step of the design element of experiments. So we're talking about designing. They talked about repetition, and they talked about blinding and double blinding, and now we're looking at randomization. And this is all into the category of designing of an experiment. So randomization is used when subjects are assigned to different groups through a process of random selection. The logic is to use chance as a way to create two groups that are similar. Again, instead of for one group getting the basketball players and then for the other group getting the ping pong players, those groups are not similar, at least in the aspect of height potentially, because the basketball players are heavily biased to being taller. And so then if I chose my groups in that way, I might create a bias between the groups, and some aspect that I want to be similar may not be. So by just choosing people randomly, you have the best chance of not creating a systematic bias and therefore having the groups be similar in nature because they were all chosen at random. So there's no reason to believe one has particularly more tall people than the other or any other aspect if they were chosen randomly. Does that make sense? All right, push a little bit further forward. So this is one of the tougher definitions. I've already had students ask me about this, so I will use this as our final one today. There's more slides after this, and you're free to check out the whole slideshow by going to the multimedia library. Simple random sample. So that, as we said earlier, that was kind of like one of the things it said very early on in the slides. It showed us this idea, and so now we're going to define it. A sample of n subjects, like 100 people or something like that, is selected in such a way that every possible sample of the same size, 100 or whatever, has the same chance of being chosen. So if I choose 10 students from the DVC student population, if every different group of 10 students is equally likely to having been chosen, then that's a simple random sample. A simple random sample is often called a random sample, but strictly speaking, random sample has a weaker requirement, only that all members of the population have the same chance of being selected. So I believe, since a couple students asked about it, you will probably have some homework problems that ask you to distinguish between a random sample and a simple random sample. And so it's pretty subtle. After I've just read it, it's probably still, for most people, very confusing. So here's an example to try to illustrate the difference between the two. So again, let's say I'm going to randomly choose 10 students from DVC in such a way that I'm trying to make I can then get their heights and try to get the idea of the random average height of students at DVC. And let's say I happen to know from numbers from administration that about half the students of DVC are women and half the students are men. And I also know that on average in the world's population, that men have an average height that's taller than that of women. So I might be worried that if I happen to randomly take any 10 people from the campus, maybe by randomly choosing their student ID numbers or something like that, that just by random chance, I might get my sample to have like 8 women and 2 men. And I might be worried that that's not a good representation of the overall population, because the women would end up leaning toward a shorter average height than the men. And if I get a lot more women just because I randomly chose 10, it might make my sample not a good reflection of the overall DVC population, where I know there's more of a 50-50 split. So in order to adjust for that, I might try to randomly choose 5 people from women and 5 people from men, so that in the end, the sample of 10 people I get has exactly 5 women and 5 men. And therefore, I have both genders better represented in the same way that they're represented in the population. So again, that's a lot of confusing discussion, but that could be done. If so, then the sample I collected of 5 women and 5 men is an example of a random sample that is not a simple random sample. And the reason is that any person at DVC was equally likely to be chosen, because I chose randomly any of 5 women and any 5 men. So whether you're a woman or a man, you are equally likely to be picked. However, I don't have the samples that I get will all be 5 men and 5 women. And if I imagine randomly picking any 10 people, they won't necessarily come out that way. And therefore, I don't have a sampling method where any 10 people as a sample is equally likely to be chosen, because there's no way I'm going to get 8 women and 2 men. So that's clearly not choosable at all, but that would be a sample of 10 that I could get. But in this case, that one has no likelihood of occurring because I'm not allowing that to happen. And therefore, every possible sample of size 10 is not equally likely because some of them are excluded entirely. It's a very hard concept. That's my best sort of initial shot at giving a simple example, and really can become more clear as you look through the examples that they provide you. I'm sure they give you some of the slides and in the homework exercises. So having read this and tried to give an example, I still expect it's very confusing. Anybody willing to share a question or want to give an example of a sampling and which kind it would be? Okay, too much to think about. We only have about 5 minutes left. So what I'd like to do to finish up then is have us just bop over and take a look at a homework problem that would be a problem based on 1.3 to just, in your mind, give you the idea and the experience of studying the material, talking about it, thinking about it, and then being in a position to try to begin doing your homework problems for this section. So let me stop this share. And then let me see if I can share over here with a homework problem. All right. So are you guys able to see, let's do this, say this next. Okay. Oh, I'm worried it's going to close the window. Let's see here. Yeah, it killed off the window. All right, let me see if I can grab that real quick. And try that again. Okay, so can you guys see this homework problem here?
Yep.
Thank you. All right, so this is number 26 on the homework that's due this Sunday, the 7th. Some of you may have completed already, but if not, this is 26 out of 36. And so it says, determine whether the given description corresponds to an observational study or an experiment. So those were a couple of the definitions that we looked at, and we did a compare and contrast. It says, in a study of 358 boys with a particular disease, the subjects were injected with vitamins to determine if the vitamins have an effect on the disease. And then it says, does the given description correspond to an observational study or to an experiment? And then there's a few choices here. So the first one says the given description corresponds to an observational study. The second one says it corresponds to an experiment. And the third one says there's not enough information provided to answer the question. So questions, comments, discussions about this, opinions, what do you think?
It's an experiment because they're applying a treatment to a certain group.
Okay, anybody else share that opinion or have a different opinion, wants to discuss it? So which choice would that be here from what you just said, A, B, or C?
B.
B. And so as we are seeing on our homeworks, as you're doing your homework, you can check your answer. And if you get it right, yay, then it gives you a little green check. And then if you go up here, as you accumulate those green checks, your score gets better and better. And the goal is to ideally get the green checks on 100% of the problems. Right now I'm scoring 5.56%. I do need to do some more work on this homework to improve my grade, but I do have until Sunday at midnight. And so that's what it looks like to go through the material, to study it, and to then be in a position to work on questions on your homework and to try to get that done, hopefully well ahead of the due dates. Questions, comments, discussions about this?
I had a question about like the random sample and simple random sample. I struggled a lot when I was doing the assignment. So I did like kind of like a research, and I don't know if it's like correct the way that I'm looking at this, but like I found that like in random sample, every single member has a chance to be selected, and maybe like in simple random sample, every group has the chance to be selected. So maybe it could be like
good.
the difference,
That's a good summary. That's a very good summary.
like that could be helpful, like better to understand the exercise.
Well, yeah, I think that's what we said, but maybe I think you said it in a very succinct way. So maybe I didn't summarize it in a clean enough way, but what you said is absolutely right. And it's basically what the definition is. That's great.
Okay.
Did you want to look at one of those, for example? Is that why you're struggling, or are you just trying to help the class? Because I think that was a really good summary.
Well, yeah, I would like to look one of the samples because yeah, I struggled a lot while I was doing the assignment, and
Do
I
you know
tried
which
to like,
problem it was? We could look at it together. Right.
no, I don't really remember.
Maybe I'll take a stab here and see if we get lucky. 29. Ooh, stratified convenience cluster. That's stuff that we did not even get to yet. So maybe if I back up a little bit, I can find where they talked about it. So there are further definitions, that's for sure. And there's ordinal, some of that stuff. Now we're in 1.2. So yeah, instead of rooting around and trying to find it, maybe we'll just, if you can come with a question in particular you want to ask about, we can talk about it together during office hours or something like that. But we are basically running out of time. So let me stop the recording and.
I had a question.
Yeah, go ahead.
Or I wanted to like see if this would be like an example of a simple random sampling.
Okay.
So let's say like I have like 30 adults and I want the sample to be, let's just say like 10 of them. And I put like, I number 1 through 10 of the adults out of the 30 population. And then I just like randomize it. Let's say just put the numbers in a hat and I pick the first 10 out of the 30. Is that a simple random sample?
Yes.
It is. All right.
Because any group of 10 from the 30 is equally likely to be chosen.
Okay. But if I did the whole 30, it would just be a random sample. If
you did what for the whole 30?
If I just randomized the whole 30 and didn't count just 10 out of the 30. Like, do you get what I'm saying?
Well, then it's not a sample.
Oh.
It's a census.
Okay, yeah, because that's the whole population. Okay, yeah,
Right.
that makes sense.
So to have a sample, the word sample means a subsection of the population.
Small portion of it.
And so you can't have all of them and still have a sample anymore.
Mm-hmm.
There has to be some chance that there's a different, like if you took 29 out of 30, that's pretty close to a census. I suggest you just grab the last number out of the hat.
Yeah.
But nonetheless, technically that's a sub-selection. That is a sample. And there are 30 different ways that you could pick 29. It's like just which person was left out. And there's 30 different people that could be left out. So there are 30 different groups of 29 that you could pick, if that makes sense.
Yeah, no, that makes sense. All right, cool.
Yeah, so hopefully you guys can see that discussion matters. Oh, we are now out of time. So I definitely want to say we are done. I'm going to stay around and answer any questions if people have them, but we're not going to cover any more, and I'm going to post the video at some point. Great job, guys. Great job getting a head start in the class, getting registered. Come see me in office hours if you have questions, and thanks for coming today. And I'll take the follow-up questions.
Thank you.
Thank you.
I had a question about the vocab. I think it was like a little bit later in the chapter, but discrete and contentious. Because I
Continue.
guess we talked about it before, but we only use like one example.
Mhm.
So
And I did actually talk about that, I think, in my morning class in the video
Oh,
that's
okay.
posted. If after we're done today, you want to have another go thing to check out.
yeah, that'd be another example.
But yeah, what are you thinking about? Or do you want me to just give you other examples or what?
Could you give me an example and I could just see if it's discrete or contentious?
Well, I actually had a really good description by a student in today's session this morning that she said she used to help her. She said, imagine somebody is like walking up steps.
Okay.
So a couple of things you could observe about that is how many steps they climbed.
All right.
And you can't really climb 2.5 steps, right?
Yeah.
So that's a discrete measurement,
Okay, that makes sense.
right? And it's finite, it's countable, just how many steps were there.
All right.
But you could also say, well, how much height was gained on each step?
That would be a contentious.
Continuous.
Oh, continuous.
Yeah,
Okay.
yeah, the first part of the word is, think of it as continue.
Yeah, I wrote it wrong. Okay.
And continuous means that all the values in the range are viable.
Yeah, that makes the
And
definition.
that's why there's infinitely many of them. There's literally a continuity of numbers, that there's no jumps or gaps from one number to the next. But
Yeah.
because that height could be anything, I mean, there may be a maximum height that's feasible, like 2 feet or something,
Mhm.
and obviously a minimum of 0. But anything in between 0 and 2 feet is a continuous range of values because there's infinitely many possible lengths of height change in there.
Yeah. Okay. That makes
Does
it
that
pretty
make sense?
solid. Yeah. All right.
Yeah, I
Appreciate
thought that
that.
was a great example that the student brought it, because
Yeah,
you can kind of
Python.
put the two things in the same context and compare them, right there.
And it's easy to visualize.
Yeah, I think so. Yeah, I thought that was great.